in geometry. Segments are congruent. Distances are equal. Okay? So an actual object are congruent to each other, but the distances are equal to each other. Okay? So, whenever you're naming a segment and it has its bar above it, so that's like saying segment AB, and you're trying to say that it's congruent to another segment. What does congruent mean? The same, right? Congruent means the same, right? They're exactly the same. That's what congruent means. So to say that in geometry, for segments, you have to use this congruent symbol, which is just, if you have a hard time seeing it, it's an equal sign with that squiggle above it. That means congruent. So whenever you're stating segments are the same, you're stating that they're congruent, you have to use that symbol. So I like to think if there's a bar above the segment, you have to put that squiggly bar above the equal sign. Distances are equal, and in geometry, to represent distance, you don't put the line above the segment. So when there's no line above the segment, you're talking about the length of that segment. So that's like, for the second part, that's like saying the length of AB is the same as the length of CD. So if there's no bar above the segment, you don't put the squiggly bar on the equal sign. So incorrectly, this would not be correct because we use the congruent for distance and equal for the same. Right. Same thing with angles. Okay. Technically, angles are congruent. The objects are congruent, but their measurements are equal. Okay. So if they have the same degree, if they're both 30 degrees, no, snuck its way in there. Scratch out that little bit. That's not supposed to have a squiggle above it. That's incorrect. Okay. It should just be an equal sign for this one. Okay. So the angles itself are the same. The angles are congruent. We use the congruent symbol. Use the equal sign with the squiggle above it. Okay? If you're trying to say that their measures are the same, you're saying that the measures are equal. Okay? So to do that, to represent that the measure of an angle is the same, you use the little m. That means measure. So the measure of angle ABC is equal to the measure of angle DEF. Okay? If you just want to say, hey, these two angles are the same, you use the congruent symbol. If you're trying to say their measures are the same, you use the equal symbol. Right? And again, I am not very picky about that. If you said angle ABC is equal to angle DEF, I'm glad that you know that they're the same. I'm not super picky about it. But it's something good to know why there is a difference and why those little symbols are. Okay. Questions about that? So first kind of vocab word that we need to talk about is a midpoint. Right? It is as it sounds. A midpoint is a point that is in the middle. Okay, it's directly in the middle. So because it's directly in the middle, it divides the segment into two congruent segments. Okay? So look at this diagram here below. Point M is the midpoint of segment AB. Since M is the midpoint, we know that AM is congruent to BM, meaning AM and BM are the same. This is directly in the middle. Okay? If you were starting out at A and walking directly to the middle, you'd walk the same distance to get to the middle from B. Okay? They're the same. Cutting that segment in half. Okay? In geometry, to indicate that segments are congruent, we mark them with these tick marks. So if you notice there's those red, now they're orange tick marks, that's showing that those segments are the same. So if segments have the same amount of tick marks, that means they're the same distance. They're congruent. If they have a different amount of tick marks, let's say we weren't told it was a midpoint, we were just given that information, that means they're not the same when they have different tick marks. Right? So if this one has 2 and that one has 1, they're not the same. Okay? But if they both have 1, then that means they're the same. They're congruent. They're the same distance. Okay? questions over that? So if we take a look at this first example in the diagram below, M is the midpoint of JK. Find the value of X. So this is what a line of geometry looks like. Is you're given enough info. You are told, you're given a diagram and you're given some info. So we are told that M is the midpoint of JK. And we're told to find the value of X. This happens a lot in geometry. You have to take what you know about what you're given to set up an equation and solve. Okay? So if we know that M is at the midpoint, what do we know about JM and KM? They're the same, right? What's indicating also in that diagram that they're the same? Yeah, little tick marks, right? So if we know they're the same, that also means they are, starts with an E. Equivalent or equal to each other, right? So if they're the same, that means they're equal to each other. Well, how can we set up an equation to solve if they're both equal? Yeah, very good. X minus 14 equals 33. Just set them equal to each other. I know that's a midpoint, I know it's in the middle, and I know those two segments are equal, so I'm going to set them equal. And then you just solve for X. So when we solve to get X by itself, what do we have to do with that 14? Add it to the other side. So X is equal to, what's 33 plus 14? It just said find the value of X. We found the value of X. We are done. Not too bad. A lot of what geometry is. Take what they gave you to set up an equation. And that's the hard part, is as we go on, you're remembering more facts. So the hard part is remembering the vocab and remembering the facts to then be able to set up your equation. Once you get your equation set up, we all did really well on that quiz. We all can solve equations. Okay. Hard part is just remembering everything to set up that equation. Another important vocab word is segment bisector. Okay. A segment bisector is any line, segment, line, or plane that intersects a segment at its midpoint. Okay. Also think about the word bisect. Kind of sounds like what? You do it in science class. Dissect, right? When you dissect something, what do? Cut it, right? Cut it, right? When you think about the word bisect or bisector, think about like bicycle. Bi means what? Two, right? So if you break down that word, essentially when you're bisecting something, you're cutting it into what? Two. And specifically, those two pieces are going to be what? Equal. They're going to be the same. So essentially, when you bisect something, you're cutting it in half. Okay? That's all you're doing. So if we take a look at this diagram here, line L is bisecting AB at point C. Therefore, point what has to be the midpoint of AB? C, because that's where it's bisecting. It always bisects to the midpoint. Okay. And then what two things are congruent? It's going right through the middle. What do we know? What two things are congruent? Yeah, AC and BC are then congruent because you're cutting it in half. So these two segments are congruent. That is congruent. Those two are congruent because you're cutting it in half. So whenever you see the word bisector in your head, you should be like, I'm cutting things in two, I'm cutting it in half. I have equal pieces. Going through the midpoint. So we take a look at this example, this diagram below. Segment DB bisects AC. Find the length of BC. So it's a little bit different than the direction from the previous problem. The previous one asked for X. This one asks for the length of BC. But in order to find BC, what do we need to find? X. right? How are we going to set up this equation to solve if I see that I have a segment bisector? If DB is bisecting AB or AC, what do I know about AB and CB? They're equal, they're the same. So I'm going to indicate that by marking my diagram with tick marks. Get in the habit of doing that. That's really helpful. Mark your diagram. I'm going to mark it with my tick marks. So if I know those are equal, well, how can I set up my equation to solve? What would it look like? I know these two things are equal if I know they're the same. On the low. What can we do? Yeah, you just take whatever's written on these two segments and set them equal to each other. It's essentially what you're doing when you have a bisector. Take the two things, set them equal. Alright, so we're going to say 4x minus 5 equals 11 plus 2x. And then you just solve for x. So to solve for x, which one do we want to move over first? 2x. I'm going to subtract to move it over. So I get 2x minus 5 equals 11. Move the 5 over. Divide by 2. 16 divided by 2 is... Are we done? We found x. No. Make sure you read those directions. We get in the habit of solving for x and being done. The directions specifically ask for BC. That's what they want to know. Right? But in order to find BC, we had to find x. Now that we have x, what can we do with it? What can we do with that 8 to find BC? Yeah, just plug it in. So whatever, here's BC, right here. We're just going to take 8 and plug it in for x. So we do 11 plus 2 times 8, because when you have a coefficient, a number written next to an x, you're multiplying. So we do 11 plus 2 times 8. Plug that in. I forgot my letter C. So when I do that, 11 plus 2 times 8 is... 2 times 8 is 16 plus 11 is 27. Okay. So we know BC is 27. Without doing any math, what's the length of AB? 27, they're the same. What's the length of the whole entire segment? 54. Yeah, I understand. From here to here is 54. Questions over that? So whenever you see bisector, that two things equal. Well, in geometry, there's a special type of bisector, and it's called a perpendicular bisector. Perpendicular bisector. I don't know what it means to be perpendicular. Talked about maybe a little bit previous classes now. A perpendicular bisector is a line or segment that intersects a segment at its midpoint, so it's bisecting it, but it's also perpendicular to that segment. Okay? And when lines are perpendicular, they form right angles. They intersect, so that right angles are formed. Right? So a perpendicular bisector cuts a segment in half, but it's also creating right angles at the same time. So look at that diagram here. M, N, R, and PQ are perpendicular. To indicate that segments are perpendicular, we sometimes use this symbol. It looks like an upside down T. So if you ever seen that symbol, that means those lines are perpendicular. Okay? So it might look something like this. M, N, is perpendicular to PQ. Okay? So we look at this diagram, how these lines are intersecting. All four of these angles right here are right angles. And again, we draw that box to indicate that it's a right angle. So when two lines are perpendicular and they intersect, all four angles that they make are all right angles. That's what it means to be perpendicular. Questions over that? So we take a look at this example. It says in the diagram below, CD is a perpendicular bisector. To me, that's an important word. I see a vocab word. I need to know what that vocab word means. Okay? If COB, right, the measure of angle COB is 8x plus 50, the distance of AO is y minus 7, and BO equals 11, we want to find the value of x and y. We need to find multiple variables. I think it's really helpful if you label your diagram. So it told me this angle right here, COB, I'm going to draw a little arrow, is 8x plus 50. So I know that angle right there is 8x plus 50. It also told me that AO is y minus 7. So I'm going to label that where AO is, y minus 7. And then it said BO is 11. So I'm going to label BO with 11. Mark my diagram. Then what I'm going to do is go back to that really important vocab word, perpendicular bisector. What did we just say about a perpendicular bisector? Just two things. What does it do to the segment? It cuts it in half. And it also creates what type of angles? Right angles. Okay. So if we know CD is cutting AB in half, what do we know about AO and BO? They're the same, so I'm going to mark them with tick marks because I know they're the same. And then because it's perpendicular, what do we know about all four angles? They're all what? They're all 90. So I'm going to put a little box here for COB because that's an angle to show that it's a right angle, to show that it's 90 degrees. Well, how can we find x? We know that angle's a right angle. We know it equals what? 90 degrees. So how can we set up the equation to find x if we know that angle's 90 degrees? Yeah, you just set that angle, 8x plus 50, and set it equal to what the angle measure is, which in this case is 90. So 8x plus 50 equals 90. If we were told that was a 30-degree angle, you would say 8x plus 50 equals 30 degrees. Okay? But we were told that it's 90 because we had that word perpendicular. So we know all those angles are right angles by knowing what perpendicular means. That's why it's really important to know that vocab. Helps you set up these equations. So when we solve, we just move the 50 over to get 40. Divide by 8, so x ends up equaling what? 12. If we take a look at y, we need to find y. So we took care of the perpendicular part. Now we're going to look at the bisector part. Knowing that it's the bisector, we said that these two segments are equal. If they are equal, Hannah, how can we set up our equation to solve for y? Yeah, when you write your equation to solve for y on paper, what's it going to look like? It will be what? Well, we know that we said because it's bisecting, we know that's the same, right? It's cutting it in half. So then we know AO and BO are the same, which means in math, they are equal. So on the other two examples, when these two segments were equal, how did we set up the equation? Yeah, just write them down, and you put your equal sign in between. You set them equal to each other. And then you just solve. To solve for y, what do we just need to do? Add 7. Get that y equals 18. So it's really important to know your vocab and geometry helps you set up these equations. Do we need to plug it back in to see what anything is? Did it ask for any specific measurements? No. I just wanted to know x, I wanted to know y. We found them. And the last thing we are going to talk about, there's segment bisectors, but there's also angle bisectors. And it's the same exact concept as a segment bisector, but we're just dealing with angles. Okay? An angle bisector is just a ray or segment that divides an angle into two congruent angles. In other words, it's something that cuts an angle in. Okay? So if we look at this diagram, CD is bisecting this big angle, ACB. In other words, it's cutting it in half. Okay? Because it's being cut in half, we know that these two little angles are the same. So I know ACD is congruent to this other little angle, BCD. So being cut in half, those two little angles are the same. They're congruent. They're the same measurement. In geometry, to indicate that angles are congruent, if I look at this diagram, we put arcs kind of inside near the corner of the angle. And if angles have the same amount of arcs, that means they're the same measurement. If they have a different amount of arcs, that means they're different. So if this guy had an extra arc here, if this had 2 arcs and that only had 1, then they're not the same. They both have the same amount of arcs, so that means they're the same. Questions over there? So last example is in the diagram below, AB is bisecting angle CAD. Find the value of x. So look for that vocab word. AB is bisecting that angle. So what is AB doing to that angle? Cutting it in half. So then what do we know about these two little angles? They're the same. So I'm going to put my arcs to show that they're the same. And if they are the same, Nick, how can we set up our equation to solve? Just like we did with the segments. When the segments were the same, what would your equation look like? Perfect. 4x plus 1 equals 33. Just set them equal. Questions over that? And then you just solve that equation to get x by itself, move over the 1. Get 4x equals 32. Divide by 4. Oh, that's a terrible 8. X equals 8. Questions over that? So if you notice, with segments, really if you're given a segment, all you can do is set them equal to each other. So if you're given segments and you're told to find a variable, all else fails, set them equal. Probably right. Angles, we can do a lot more with angles. We can set them equal, but if you also notice from example 3, we also set it equal to them. So you can set angles equal to measurements, you can set them equal to each other. You'll see next unit, we can add them and set them equal to something else. But segments, if all else fails, set them equal. Angles are a little bit trickier. If you're unsure what to do with segments, set them equal. Because you're probably right. Questions?